Yeah, what up, guys? Still awake. Helping you on 2.7. Just helped you last time on 2.6. Whoa, look at the Magic Gathering for a second. Let's open a pack together. Woo! Open a pack together. Innistrad Midnight Hunt is the latest Magic Gathering stuff. Yeah, just need 4 more to get another rare card of my choosing. Target player draws 2 cards. We got, a Siege Zombie. Tap 3 and tap creature you control. Each opponent loses life. That's cool. Ooh, Hungry for More. Create a 3/1. Black and red vampire creature target with trample life again. Haste. Sacrifice at the beginning of the next end step. That's crazy. That's crazy. Trample life encased. Phantom Carriage enters the battlefield and search your library for a card with flashback or disturb. Put in the graveyard, then shuffle. Ooh, so lets you search. And here's the rare. Briarbridge Tracker. Human Scout. 2/3. He enters the battlefield, investigate. As long as you control the token, he gets +2/+0. 4/3. Vigilance. That's sick. I like it. Nice. Okay, get out of that new rule. And there we go. Okay, so last time I left off, I noticed on the video at the end of 2.6 that I made a mistake. Trying to fix that. So that mistake is that this was a -4, good. This was a +3. And then this was a +2 squared, which is 4. So that means this should actually be negative, and this will actually be negative. So that's the Y-intercept, beautiful. So using this information of roots as well as multiplicities, that helps us to graph this, which is basically 2.7. And so 2.7 is going to be graphing. And so how that works is, first of all, you look at the leading term, which we figured out was an x to the 4th power. Beautiful. And so what is x to the 4th power? Well, first of all, it's even. And since it's even, it's going to be in both directions. It's either going to be up, up, or going down, down. Well, since the leading coefficient is positive, it's going to be both going up, up. So I would go ahead and make a graph like this, and I would point upwards and point upwards. Now we're going to look at the roots and know where to graph this. So not -4, but a +4, we're going to cross through. So 1, 2, 3, 4. We're going to cross through, because that's one of the roots. It comes from those parentheses that you might have to factor first, possibly. The other root is going to be a -3. So 1, 2, 3 has a multiplicity of 1. So at -3, we're going to cross through. And then at 2 squared is actually an even number. It's not a multiplicity of 1, it's a multiplicity of 2. And so what's 2 or 4 or 6 or 8, if it's even, that means we're actually going to bounce. We're actually going to bounce off of the x-axis. So bounce off of the x-axis, right? That's Granddad's clock saying, Newbold, you need to go to bed. You're being crazy now. 3 o'clock is crazy about making a video for your math students. But you love them, so you better just hurry and finish it. Okay, so at x + 2, it's actually going to be... Oh, did we make another mistake? No, it's a no, it's positive, good. So that was okay for the y-intercept. But you will use a negative root there, which is good. With the multiplicity 2, which is like a spring, so it means to bounce. So at -2, here it goes, ready? So we're going to cross through, because -3 to the 1st power. So we're going to cross through -3. Then at -2, we're going to bounce. Boing! And then we're going to come all the way down to -48, which is our y-intercept. I know it's not to scale, sorry about that. And then it's going to cross through a 4. And there's our graph, x to the 4th power. So not the best looking graph, not to scale, but still it works. So let's go ahead and take a look at our assignment then, 2.7. Maybe a harder one might be 13. We have to do some stuff first. So let's take a look there. Okay. So then this is x to the third power, and then minus 9x. So they already gave us the leading term on this one. And so the leading term is just going to be already multiplied out for you. So it's x to the third power. Nice. And the y-intercept, maybe not sure. So maybe we need to factor that sucker out. For the y-intercept, set x equals 0. Might just be 0. Let's see. So I'm thinking we could pull out an x, right? They both have an x in common. And when you pull out an x, what are we left with? Well, we're left with an x squared minus 9. Because we pull out an x, 3 minus 1 is x squared. And then x is canceled there, so it's 9. Oh my goodness, this is a difference of squares as well. So that means we're going to factor that into an x minus 3. And because there's no middle term, look, I told you factoring and everything we do. So an x plus 3. Cool. So then, let's see here. So when we're finding the y-intercepts, remember we set x equal to 0. So that becomes 0, that becomes 0, that becomes 0. Wow, nothing is actually going to happen because 0 times everything is just 0. So that's actually a 0. That's crazy. Now we do have zeros at, so this is technically a what? Technically a what? So this is technically an x plus 0. And so to find the zeros, you set each of them equal to 0. And so we're going to minus 3 to the other side. So we are going to have an x equal to a negative 3 as one of our zeros. I think the multiplicities are all 1, 1, and 1. So multiplicities 1, 1, and 1. We have at x equals 0. This one we're going to add 3 to both sides. So we have a positive 3 and a negative 3. Okay. So then the end behavior comes from this guy, which is a positive leading coefficient. And positive leading coefficient. And it's an odd degree. And so that means it's going to go something that's going to like this, or it's going to finish off positive. Right? So as x goes to the left, negative infinity. Y is going to go to negative infinity. As x goes to the right, positive infinity. Y is going to go to positive infinity. Again, as x goes to the left, which is negative infinity, y goes to negative infinity. As x goes to the right, positive infinity, y is going to go to positive infinity. So that means as we go to the right, it's going to go up. As we go to the left, it's going to go down, and that is x to the third power. Now it has roots at 1, 2, 3, and 0, and negative 1, negative 2, negative 3. So now we're about to do 2.7 more Keurig. We're going to graph this sucker. So see how the end behavior kind of does the graph and sets it up? Okay, so it's all going to be crossing through because the multiplicity is to the first power, to the first power, to the first power. Right? Let me erase some zeros because we plugged in a lot of zeros there. There we go. So first power, first power, first power. Beautiful. There we go. Let's get rid of that guy. Okay, that looks better, huh? Okay, so at x equals 0, because you said that equals 0, add 0 to the other side. It's going to cross through at negative 3 and positive 3. So we're going to go through, up, hit our y-intercept at 0, down, and then at 3. Now it didn't quite give us the minimum and maximum, but maybe if I, like, I don't know, just told you what it was or used your graphing calculator, that could tell you if it was like 2 or 3 or something, not sure. but we could use a calculator to help us to see what those are. Calculator. On test, we'll give you a picture and ask you just to kind of guesstimate what those y values are. If it's -2 or maybe -3, we're not sure. Okay, so that's actually a graph. So you want to look on Canvas at those different graph-like choice options and choose the right one. So this was number 13. So if we go back to Canvas and see how this actually works. So I didn't have time to put every single graphing problem on Canvas, but I chose maybe is this 1 or 2 or 3 on the worksheet. So is this 13 or 14 or 15 on the worksheet? Let me see. Oh, it only goes to 12. Choose the equation below that creates this graph. Well, at -5, it crosses through. It's both. Let's take a look. So this is number 13, by the way. But for this one, let's see. So it's both going down, right? So it's negative is the leading term. So both going down. It's also even. So that's really, really good to know for this problem. So we're looking for one of these that when you multiply it out, you get a negative even. Well, this is negative. This is x squared. X to the first power. And x to the third power. Well, when you add those powers, it is going to be, let's see here. So 3, 4, 5, 6. So negative x to the 6th power, which is both going down. And then at -5, and then it wiggles through at 1. Excellent. And then at +3. Oh, +3 and +1, yeah. So I have a sneaky suspicion that it's that problem right there. Oh, there's more? Ah, crud. Now it's either this one or this one. Well, it's opposite sign, so if that's a +5, that's a -5. Good, that's a -5. That's a +5. No, no, no. So it's definitely going to be that one. Choose the graph that represents this polynomial. So again, you can multiply it all out. X to the 3rd power. It's positive, so probably A. Could be B. Dang it. Could be C or D. So that means you need to look at the factors. And that probably also means that you need to factor it. So do you remember this is going to be factoring into a, let's see, what does this factor into? An x plus 2, and maybe another x plus 2, because 2 plus 2 is 4, and 2 times 2 is 4. Ooh, so how many x plus 2's do I have? I have 2 of them. And that means that you're going to be looking specifically for a graph that not +2, but at -2, it bounces, right? Because even multiplicities bounce. X to the 2 to the 4 to the 6. So we're looking for at -2 it bounces. So I think it's A. At -2 it bounces. Could be C. And so it could be A or C. What else could give it away? Well, at -3 it crosses. At -3 and -3 it's going to cross through. So -3 crosses through. No. -3 it crosses through. Okay, so I hope that helped you. Feel a little bit more awake. So maybe I should just not go back to sleep. No, you need to sleep. You will be healthy. You too. Get some sleep. Go to bed now. Well, it's only 8:12 your time, but maybe you should. Thanks for watching. Hope this helped. Email me if you need more help. Thanks for watching. Bye for now. England, we made it. It's a miracle.